Let's continue. So this is just the same as earlier, except we have more resistors. So a 9 volts battery whose internal resistance R is 0.5 ohms connected in the circuit shown in the figure. How much current is drawn from the battery? What is the terminal voltage of the battery? And what is the current in each resistor? So let's just try to assume, okay? So if we were to have some theoretical, so if we theorize, so if we were to compare the values of the current drawn from the battery, terminal voltage, current of each resistor, so we know that ignoring or making or neglecting the internal resistance of the battery would of course give us bigger current values because we have a greater voltage. So of course we'll have higher current, assuming that the resistors remain constant. Okay. Now to get the current drawn from the battery, meaning to say we need the total current, what we can do here so is to simplify first. What the first easy thing is, we always start with the inside or the inner resistors. So we know that we have a parallel resistor here, 8 ohms and 4 ohms. We can have an equivalent resistor. Okay. So we have to find their equivalent resistance. Okay. So let's label this first. Let's say this is R1, R2, R3, R4, and R5. So equivalent of resistors 2 and 3. So that will be 1/8 plus 1/4 to the negative 1. So let's try to calculate. That's going to be 8 over 3. So we have 8 over 3 ohms. And then we know that this equivalent resistor is in series with R4. So next equivalent would be REQ234. That is 6 plus 8 over 3 ohms. Okay. And we have to add, that will give us 26 over 3 ohms. So that new resistance will be simplified. Say for example, it's this one. Now let me choose another color. Say blue. Okay, suppose this is R equivalent to 3, 4 across R1. So we know they are parallel. So let's find 1, 2, 3, 4. That will be 1 over 10 plus reciprocal 3 over 26 to the negative 1. This will give us a value of, so 1 over 10 plus 3 over 26 to the negative 1. 65 over 14. Let's stick with the fractions. Ohms. Okay. This time, that will already be, say, this equivalent resistor here. Suppose this has been REQ1, 2, 3, 4. And this equivalent resistance is in series with R5. So the final net resistance, excluding the internal resistance of the battery, will be 65 over 14 plus 5. And that will be 135 over 14 ohms. Okay. Now lastly, so we'll try to determine the current. So total current, that will be, we're going to divide EMF over 135, sorry, what did I do? Okay, 135 over 14 plus 5 ohms. This is equal to, so we have 9 over 135 over 14 plus 5. Okay. Let's sorry, let me reiterate. Okay. This is 0.5, sorry. 0.5. Okay. So you have 0.887 amperes. This is the current drawn from the battery. Next will be terminal voltage, V. Okay. That will be 9 minus, so we have 0.887 amperes times internal resistance 0.5 ohms. This will be, or this will give us 8.56 volts. Okay. Lastly, current in each resistor. Okay. So here, let's try to see. Okay. We have to, if we're going to have the current in each resistor, that means we'd have to break this down. Okay. So to determine, let's have first, we try to do the reverse. Okay. We have REQ 1, 2, 3, 4, and 5. And so the current across 1, 2, 3, 4. So this is in series. That's just equal to total current. That's also equal to current across resistor 5. Sorry, this is I5, which is 0.887A. Okay, so I5 is done. Then we do the reverse. We break down equivalent resistance 1, 2, 3, 4. Okay, but what we'll do here is we're going to use the voltage voltage drop as well. Okay, so voltage drop, we'll have to consider, so the sum. Okay, now we know that current passing through times value of resistance, that's the voltage drop. So we have here V equals V5. We have 0.887 amperes times 5 ohms. Okay, and then so we're going to have the voltage drop so that we will know the voltage that will pass through equivalent resistance. Okay, 1, 2, 3, 4. So that will be including this, so terminal voltage from A to V, so that will be 8.56. Okay, rather, so let's consider, so voltage Lagi, terminal voltage. So why will we not use 9 volts? That's because of our internal resistance. Okay. But then we already considered internal resistance. We know current flowing is equal. But we still have to consider, because if we try to add up, okay, zero point 0.5 times 0.887 plus 5 times 0.887 plus 135 over 14 times 0.887, that's excess. Okay? So meaning to say, we no longer have to include. Okay? So we don't have to consider. Okay? Because we know that the current is equal. Okay? So here, V5 equals, so 0.887 times 5, we have 4.435 volts. Okay. For one. Okay. So going back, so as I have mentioned, they have equal currents. And so we're going to consider also the internal resistance of the battery. Okay. So before we break down the combination or the equivalent resistance. Okay. Now to find voltage drop, this will be, so 9 volts minus V5 minus, say, the current 0.887 times 0.5. This one, this equivalent voltage, so this will be, so 9 minus 4.435 minus 0.887 times 0.5. We have 4.1215 volts. And then this equivalent voltage drop, it passes through. So we have to consider. So from 1 to 3, 4, it becomes, so parallel. So meaning to say, voltage equivalent 1 to 3, 4 is just equal to the voltage drop across R1 and our equivalent resistance 2, 3, 4. And after that, so you're going to get already equivalent for 2, 3, 4. Then we revert to equivalent between R2 and R3, and then we get the smallest, or back to the old circuit. Okay. Determine the net resistance of the circuit connected to the battery in the figure. So this is actually somewhat a tricky. But what will be your guide? What your guide will be here is the nodes or these junctions. Okay. If we try to think about it, so there are relationship between these resistors. So for instance, these two, they are actually considered series. And getting their net resistance would be in parallel with this resistor. And by this node, this equivalent resistance is in series with this resistor. And then once this resistor, say this is 1, 2, 3, and 4. So getting R equivalent 1, 2, 3, 4, that is in parallel with say R5. And lastly, R5 and R6, they are in, so we're going to have R equivalent 1, 2, 3, 4, 5 is in series with R6. And that's how you're going to get the net resistance. So we have here, so first we have R plus R. We have 2R. So since they have all the same values. And then parallel, so we have 1 over 2R plus 1 over R to the negative 1. So this will give us 1/2 plus 1 to the negative 1/2. To the negative 1 is just 2/3. This is R equivalent 1, 2, 3. This is R equivalent 1, 2, 3. Then series with R4, so you have 2/3 R plus R. This is R equivalent 1, 2, 3, 4. So 2/3 plus 1, you have 5/3. So R equivalent 1, 2, 3, 4 is 5/3 R. And then it is in parallel with R5. So we have 3 over 5 R plus 1 over R, negative 1. This is R equivalent 1, 2, 3, 4, 5. So we have 3/5 plus 1. 8 over 5. Then reciprocal, so we have 5 over 8. Lastly, R6 is in series with our equivalent. This is the net resistance. 5 over 8 R plus R. Plus R equals R net. Net resistance is equal to 5 over 8 plus 1, or 5 over 8 plus 8 over 8. That gives us 13 over 8 R. This is the final answer. That's it for series parallel. Stay tuned for the last, which is Kirchhoff.